There's no homework due.
Oh,
So,
I'm glad.
no, pause.
Okay.
Pause. There's no homework due today. So we're not going to our spirals. We're not doing our color pens. Procedure, you guys know exactly what to do. Prove to me you know the procedure of what you're supposed to do when you come in and the homework is not due. What's the very first thing you should do? Open up your notes, have your pencil, just chill, and you're ready to go. Okay, it's the very first thing we should do anytime homework is not due. Now pause. Prove to me that you are an intelligent human being, which you are. And we don't always feel like it, but you are. But, yeah. Procedure. What do you think the procedure is I expect you to be able to do the day a homework is due?
Take out the homework spiral.
Yeah, homework spiral colored pen. Perfect. Thanks, Ryan. And Joel. Right? Whenever a homework is due, just have your colored pen already on your desk, ready to go. Josh, you have a question then? I'm not sure you need that for this class. Why don't you wait until after this class is done unless we have a... Okay, so then coming down. Coming down. Or coming back. Your notes are open. We're right here from yesterday. And hopefully you have your patty papers close. If you don't, well, you can just kind of pretend. Here's my patty paper. I actually have a better one back here.
I destroyed mine.
Quiet down. Yesterday, cool kids. Yesterday. We were trying to figure out at the end of class a 30-degree one, right? Yesterday, we were trying to figure out a 30-degree one. Now, I'm going to go ahead really quickly. And I did not make the lines very dark for you for my example one yesterday. So let me make it dark. I had a better one, but got lost somewhere. Question. Can you look at the circle that I have marked on the board, which you should have pretty similarly marked on your paper and your notes, right?
Yeah.
The patty paper we're just using in order to be able to get these angles nice and as precise as possible. What angles have we already marked in our notes on the unit circle? 90s and 45s. We could say 180s and 360s as well. We've marked 90s and 45s, right? Okay. Now with our 90s and our 45s, how did we get the coordinates, the x's and y's, which relate to the sines and the cosines? How did we get the coordinates on the axes, on the x-axis and the y-axis, the negative x-axis and the negative y-axis? They are cosines and sines, but how did we get them? What's the radius of a unit circle? Oh, so the farthest you go out is what unit? 1. So x was 1, y was 0. At 90 degrees, or 1/2 pi, 1/2 calzone, it's just x is 0, y is 1. At pi, -1, 0. Just thinking of graphing points, right? If we can only go out 1, well then that's going to be 1, 0. Go up 1, 0, 1. Go back 1, -1, 0. Go down 1, 0, -1. That's how we got these points. And we thought about halves of our calzone, because a calzone is like a, if you want to think about it as a taco, or a calzone, or a half circle. That's 1 pi, right?
Yeah.
So, how did we know this was 1/2 pi? Well, how much, what portion of a half circle is it? 1/2. So it's 1/2 a calzone, 1/2 a taco. If I get over here, it's 1 whole pi. If I get down here, I have 1 and a half, 3 halves. 3 halves. And if I get over here, I have 4 halves, or 2 whole. But then we took our 90 degrees yesterday. Let me mark that 90 degrees real quick. We took our 90 degrees yesterday, and didn't we cut that in half?
Yeah.
Okay. That fold was really easy. Took the 90 degrees, or the pi over 2. Okay. Took the pi over 2. There we go. And we cut that in half. We folded it, trying to make our little arcs meet. We folded it just strictly in half. What angle did that form? 45. 45. Now question. How many, if you guys were to hold this, go ahead and get your 90 and fold them in half. Get your 90, fold them in half. Get your pi over 2 and cut him in half.
I'll do it.
Question. How many, in the top half of your unit circle, how many of these slices would there be?
4.
So it's 1/4 a pi. 45 degrees is 1/4 a pi. Because you cut pi into 1, 2, 3, and 4 slices, right? So then we knew every pi over 4. How many 4ths do you have here? 1. You always just think of it as you're eating in a counterclockwise way with a positive angle. Here would be 1/4. Question, how many 4ths would it take to get over here? 3/4. How many 4ths to get here?
4.
5 4ths, right? How many 4ths to get here?
Oh,
7.
6, 7, and then how many fourths to get back? 8. Oh yeah, duh, because if you have 2 whole, they're both cut into fourths, that'd be eating 8 pieces, right? So if you're 1 away from 2 whole, that'd be 7. If you're 1 more than 1 whole, that'd be 5. You're counting in fourths. Now, we just said that's a 45-degree angle, so what triangle does that relate to?
45.
And so my visual people or my geometry people, looking at this triangle, a 1, 1, root 2, you could find all of your sines and cosines just looking at the triangle. Because you could say, from this triangle, if I know it's pi over 4, or 3 pi over 4, 5 pi over 4, 7 pi over 4, they're all over 4s. I know I'm going to this triangle. So I could go ahead and find my sine just by saying, let me get rid of this sine for a triangle. I don't need him. It is in my way. Geometry people, Sokotoa Choshiko. How could I find how could I find sine of 45 or sine of any over 4 with pi? How could I find the sine of anything with this triangle? Wrong one, sine. Sokotoa. Which is opposite over.
I thought we were doing Choshikawa.
Not yet, not yet.
Oh.
Now wait, we don't leave an answer like that, right?
No.
What do we do to it?
Simplify.
Rationalize, right? Multiply top and bottom by root 2. Do you guys remember from last year, root 2 over 2?
Yes.
That was a number that was pretty important last year in the unit circle, root 2 over 2. But you could get it just by doing opposite over hypotenuse. How about cosine? Adjacent over hypotenuse. Wouldn't that be the same thing?
Yeah.
How about tangent? Opposite over adjacent. Well, that's just 1. That's easy. Could we keep on going and could we do cosecant? Okay, now we're at Choshikon,
Yes.
which would be hypotenuse over opposite. No, cho. Hypotenuse over opposite. How can we do secant? Sha. Hypotenuse over adjacent. Root 2 again. How can I do cotangent? Ow. Adjacent over opposite. Look, you found all 6 trig functions of pi over 4. What changes if they give you 3 pi over 4, or 5 pi over 4, or negative pi over 4? Are the numbers going to change?
No.
What's the only thing that's going to change? Look over here. What changed in our points? Just the negatives. Just the negatives. So if your brain likes the triangle idea, like, oh, I get that and I can do all 6, you can do whatever they need you to do using Sokoto and Choshikao.
Yeah.
How can you figure out the signs? What does ASTC stand for? All students take calculus. We try.
Chemistry?
No, I guess it did. Oh, yeah, that's true. Makes a little more sense. Everybody. Okay, hold on. All students take chemistry, or all students take calculus, or all students
Classes.
take classes. There you go. Okay. What does the all stand for? What does the A stand for? How many are positive in the first quadrant? So if you figure out the angles in the first quadrant, everybody's positive. What would I change if I was in the second quadrant? What does S stand for? Sine is positive. This is a positive statement for me anyway. All students take calculus. Yay! Okay. Positive. So if I was in the second quadrant, I would come over here and I'd say, okay, this guy stays positive, and his reciprocal stays positive. Everybody else negative, 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 negative. Ha-ha. Third quadrant. What's positive? Tangent. And his reciprocal. So I would say, oh, negative, negative, positive, negative, negative, positive. Fourth quadrant. Who's positive? Cosine. And here's reciprocal, which would be ka, adjacent over hypotenuse, and sha, secant is hypotenuse over adjacent. So cosine and secant, those two would be positive, but everybody else negative, 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 negative. Okay? That's one way of doing it, using a triangle and using all students take calculus to put it in the right quadrant. However, you can also use the x's and y's. And when you use the x's and y's, you could say, okay, for those of you that just like to memorize and you like to know these little ordered pairs, if I were to ask you for, looking at the ordered pairs, not the triangle, if I was to ask you for tangent of 7 pi over 4, if you could get that to be in the fourth quadrant, 7 out of 8 slices, or just say take 4 and take 3 more, or take 1 less than 8, either way ending here. if you could attach this x and y coordinate, then you could say, okay, who's cosine? This guy. Who's sine? That guy. Positive is the x, that's cosine. Negative is the y, that's sine. Who's tangent? Y over x. Well, what would happen, kiddos, if I take y over x? Some of you, this would get a little bit nasty if you use the formulas we wrote down. Y over x.
That's
Wait.
nasty.
They're the same, nasty.
Oh, it's 1 and 1.
So it's just going to be -1. Oh, that's what happens.
Easy, easy.
So don't be stressed by the fractions. You can do math with them as well. It just might be a little bit nastier. It might look a little nastier than the triangle. Okay, now here's, we got 45s yesterday. They were over 4s. They went with this triangle in geometry. Now it's time to go to 30s. Okay, you guys, this was a little nasty at the end of yesterday. I'm going to go ahead and mark my 45 degree. I explained it in a different way to period 5 and it worked out a little bit better. So ready? I'm going to mark my 45 just so you guys can all see. All right, there's my 45.
Yes.
Some of you got this fold yesterday, some of you didn't. Go ahead and get your 90 degrees. If you want to, you can mark your 45 to look like mine, or you can just realize, hey, my 45 is the 90 cut in half, right?
Yeah.
Okay. Here's what you're going to do. Pinching the center of the circle. Pinching the center of the circle. Ready? What you're going to do is you're going to take one end. You're going to fold it to where it meets the 45. Don't push down. Fold it to where it meets the 45. You can even like hold it up to the light. I guess you can do it facing yourself also. I'm just doing it facing you so you can see. Fold it to where it meets the 45. Go a little bit past. And if you can hold it up to the light, that helps. You're trying to get it to where, when you look through, these two slices that you see are both about the same size. So, take this side, hold it here. Then you want the shadow of your fold to be about the same size as the little empty one that's left over after the fold. So maybe go just a little bit past. So go to the 45, go just a little bit past, hold it up to the light, and try to make it so that they're about the same size. The shadowed one and then the light one. Fold it a little bit past the 45, and then try to make it like mine are about the same size. It's kind of hard for you guys to see this way. It's easier for me to see this way because it's like one's dark and one's light. And they're about the same size. If they're about the same size, pinch it, fold. Pinch it and fold. And then you can curl this side around. And you might not have it perfectly, but it should be pretty close. It should almost meet up on the other side. Should almost meet up on the other side. If you curl the other one around, it should almost meet up on that other side. If you did that, right now you just cut this into thirds. There's one flap here, there's another one here, there's a third one there. I have 1, 2, 3. I cut my 90 into 3 pieces. Did you cut your 90 into 3 pieces? Cut your 90 into 3 pieces? Okay, now I want you guys to go ahead and fold that back into that third. Okay. If you hold it onto your notes, hopefully, you should about be able to, if you trace this line and follow it, you should be about to fit almost 3 of these in there. So I'm going to go ahead and trace this really quickly. Putting it on a positive x-axis, let's trace this line. It's going to be a little bit below that 45. Not that little though. I'm going to orient my board really quickly. It was messing me up yesterday. Trace that 30 degrees. Kind of like the 99-cent store. How it goes on.
What? You go to the 99-cent?
You don't? Those
No,
little machines that like.
because it's ghetto and it's dead. And if I go on there, like, you get a lot of rate.
It's even worse than
It
that.
happens.
Struggle. It happened? Do you guys have the third being about where I drew it? I didn't quite
It
draw the center.
happens. I didn't say it happened, okay?
You know what? You got anything that's white? No.
Okay, kiddos. We're holding up our little 30-degree that we made. We're trying to trace it on our unit circle in our notes. It should be about there, a little bit below 45. I don't know why it's being so difficult today, but. Should be about there, right? If we just cut our 90 into 3, if you guys want to approximate it, you can. 1, 2, 3, 4, 5. What did we just cut that pie into? Oh, we cut 90 into thirds, but remember there's 2 of those in one whole pie. So we cut it into sixths. This is going to be pi over 6. Now question, if we just cut this whole thing into sixths, this whole pie, this is 1/6, right? If we have all but 1 of a pie, then how many sixths do we have? If you go over in the second quadrant, you increase that angle again, right? You're going to get right about here. How many sixths do you have if you have all of them but 1? 5/6. That's going to be 5 pi over 6. What if you have 1 and go in the third quadrant, trace them again. What if you have 1 whole pi and 1 more sixth? You have all these pieces and 1 more. 7. You have 6 plus 1. You have 7 pi over 6. And what if you have all of the 2 calzones but take away 1/6? So now you trace this one in the fourth quadrant. Because if you have 2 whole, they're both cut into 6s, that's 12, but take away 1, that's 11 pi over 6.
The first one, pi over 6.
Yeah, the first one's pi over 6. We get closer. There it is. So you can trace this little 30-degree angle. In the first quadrant, that's 1 pi over 6. Now I have all of them but 1, that's 5 pi over 6. I have all of 1 whole calzone plus another one, that's 7 pi over 6. And I have all of the 2 calzones minus 1/6, that's 11 pi over 6. Now hold on. What angle is this if we took 90 and cut it into thirds? 30. Oh, that's going to be this triangle, right?
Yes.
Okay. So this triangle, there's 2 different ways of looking at it. We knew we did yesterday where we scaled the triangle back. That doesn't look like a 30, it's a 45, 45. You can scale this guy back to fit in the unit circle. And if I do that, the radius will be 1, but to get it to be 1, I have to cut everybody in half. So one way is just to say, well, to take this geometry formula, or this geometry triangle and get them in the unit circle, I have to divide everybody by 2. So the x is going to be root 3 over 2, the y is going to be 1/2. That's one way. Those are those coordinates some of you memorized last year. Root 3 over 2 and 1/2. Now kiddos, if you're able to get the root 3 over 2 and the 1/2 in the first quadrant, all you have to do to finish off the rest of the coordinates is to think about how do the signs change. What's x going to be doing for 5 pi over 6? Instead of moving to the right square root 3 over 2, it's going to be moving to the left, which means what sign?
Negative.
Yeah, negative root 3 over 2. But the y, isn't it still going up just like it was in the first quadrant? So that's going to be 1/2. How about in the third quadrant? I'm moving to the left and down. What's going to happen to my x's and my y's?
Negative.
They're both going to be negative. So negative root 3 over 2, negative 1/2. How about in the fourth quadrant? I'm moving to the right and down.
Positive x.
Positive root 3 over 2. To the right, but down. The y needs to be negative. And if you guys follow your all students take calculus, it would tell you the same thing. But if you're more of a geometry person, couldn't you think about any over 6, any over 6, pi over 6, 5 pi over 6, 7 pi over 6, 11 pi over 6, any over 6 is going to be cutting 180 into 6 is 30 degrees. It's going to be this triangle, and I could figure out sine of theta, opposite over hypotenuse, cosine of theta, adjacent over hypotenuse, tangent of theta. Ooh, opposite over adjacent. I think I need to rationalize that, right? 1 over root 3 is going to be root 3 over 3. Then I could do my cosecant by flipping sine, or hypotenuse over opposite. So my secant by flipping cosine, hypotenuse over adjacent. Oh, I'm gonna have to rationalize him too. And then cotangent, adjacent over opposite. So we can technically find all 6 trig functions from the x's and y's from those formulas that we talked about yesterday and the day before, just a little bit. But we can also take the triangle and just solve for whatever they ask for us, or from us. As long as we attach the pi over 6's to 1/6 of 180 to the 30-degree triangle. Once again, you can use all students take calculus if it's in a different quadrant to go ahead and solve. We have one last one. I want you to take your 6th, 30 degrees, and I want you to make 60, not 90. I want you to make 60. Whoa. Take your pi over 3. Do one unfold, not the second unfold, but just one unfold. You should be looking at 2/6 right now. 2 slices of 1/6, right? You should be looking at 2/6.
You should, Jordan.
There's your 1/6, unfold just one side. Okay, what's 2/6 as a fraction?
2/6.
1 over 3 when you reduce.
Are you?
So, if I go to my first quadrant, here's my last one. Let's measure 1/3, which is the same thing as 2/6. So take your 2/3, take your 2/6, take your 1/3, and let's go ahead and trace that one. You should end up with 1 a little bit above the 45. And come in the second quadrant. Oh, hold on, wait a minute. This is 1/3 of pi, so that's pi over 3. What if I'm over here in the second quadrant and I have 1/3? You can even rotate it if you want. The second one should be 2/3. One third, 2/3, 3/3 is going to make 1 whole pi. What if I keep on going down another third in the third quadrant? So I have all of 1 calzone. That's 3 pieces, right? If it's in thirds. So you can count around. 1/3, 2/3, 3/3. What's the next one going to be? 4/3. Or 4 pi over 3. You keep counting around. The next one's going to be 5/3. If you keep rotating your little third, the last one is going to be 6/3. You're all the way done with your 2 pi. So you can take your third, and you can measure. Pi over 3 is in the first quadrant, 2 pi over 3 second quadrant, 3 pi over 3, well that's 1 whole pi. 4 pi over 3, third quadrant, 5 pi over 3, fourth quadrant, 6 pi over 3. Done. Hey guys, if I multiply 30 by 2, what angle is that? 60. What triangle is that? The 30 turned on end. The 30 flipped. And the nice thing about the 30 flipped is, well if he's flipped, can't I just take this triangle and then just switch his opposite and his adjacent? So now I have root 3 over 2 and 1/2. Booyah. So all I'm going to do is take my original point for the pi over 6 and say, hey, it's the exact same triangle, but it's flipped, meaning the x is now the y and the y is now the x. So it's going to be 1/2 and root 3 over 2. Hopefully by now you kind of get a feel for it. If you're in the second quadrant, the x is now negative, or the cosine is negative, the y is positive. Third quadrant, they're both negative. Fourth quadrant, the x is positive, and the y is negative. That's our whole unit. Measuring by sixths, 30 degrees. Fourths, 45 degrees. Thirds, 60 degrees. And then our axes are our 0s, our 90s, and our 180s. Now here's the crazy thing. My mental mathers, if you look at all the x's and y's, not like of the crazy 6 trig functions, just the x's and y's of the points, my question to you are, how many x's and y's are there really for you to get straight? How many numbers? What are the different options for x's and y's? What's the lowest value x can be? The smallest. The smallest, sorry. -1 is the most negative, that's true. But the smallest value, take away the signs. What's the smallest x can be? No, that's the biggest x can be, right? That's the furthest x can be. The smallest, so that's smaller, that's smaller, that's smaller. Oh, 0, yeah. The smallest x can be is 0. How about y? What's the smallest y can be? 0. Okay, question. What's the second smallest x can be? Look at all the numbers in the x's and y's. What's the next biggest one? Or the next smallest one? If 0 is the smallest x can be, the next one would be, oh yeah, 1/2, right? What's the next one? Root 2 over 2. The next one, root 3 over 2. And what's the biggest x can be? 1. Okay. Can you look at all the x's, all the y's? Are these the only numbers that are actually in any of the x's and any of the y's? Not the signs, but the numbers.
Yes.
So we only have to get 5 numbers straight and we'll be good? Ultimately. Am I memorizing, people? This one's for you. You only have to get straight these 5 values. Lowest, going up to biggest. Okay? Memorizing, people, you only have 5 numbers to get straight. All students take calculus will help you with signs. I'll give you a way called the cheater chart in just a second. Visual people, you only have 5 numbers to get straight. Think about your angles. We've already kind of figured out the 1, 0, 0, 1, negative 1, 0, and 0, negative 1. At pi over 6, do you go over a lot or over a little? Comparatively, though. Compared to the other overs that you could go. Do you go over a lot or over a little? Over a lot. So if 1 is the furthest out, you can go over a lot. That's always going to be root 3 over 2. If you go up a lot, it's going to be root 3 over 2. If you go over a lot, it's going to be root 3 over 2. Over a lot, root 3 over 2. Up a little. That's 1/2. Over a lot, root 3 over 2. Up a little, 1/2. How about pi over 3? He's over a little, up a lot. 1/2 root 3 over 2. Pi over 4 is, well, he's at 45. They're the same thing. He's in the middle. Over middle, up middle. What am I talking about? If I give you something like, for instance, find the sine of, let's do 5 pi over 3. Kiddos, what quadrant would this be in, 5 pi over 3? If you hate radians, you can say, well, forget you, radians. I'm just going to go ahead and do my conversion. And I'm going to do the math and not be scared of it because I like degrees that much. Okay, you can do that. 3 into 180 is 60. 5 60s is going to be 300 degrees. Okay, you could do all that work. Or you could say, wait a minute, I'm counting by thirds. So I take my circle. Counting by thirds, there's 1/3, 2/3, 3/3, 4/3, 5/3. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Where am I at? 5 pi over 3. Which goes over a little, should be a little bit down. Over a little, down a lot. That's going to be over a little, down a lot. Sine is going to be the opposite one, which is always the y. Negative root 3 over 2. Dun, 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 dun. Some of you, the visualization is going to stick because you can visualize where 1/6 is, 1/4 is, 1/3 is. You say over a lot, that's always root 3 over 2. Up a little, that's going to be 1/2. The pi over 4 is going to be the same every time because the x's and y's match. They're isosceles, it's a 45, 45. Okay, that's one way to visualize. You can use the triangles. You can visualize with little and lot. Here's the cheater chart. You ready? Let me get rid of this page real quick. Where's my cheater chart? It's hiding. Okay, I'll put them in. Cheater chart. You ready? I want you guys to tell me to go when it hits the 3. Tell me to go when it hits the 3.
Go.
I'm Oh, dear.
What's happening?
How is you writing your
And it's all legible.
Under 30 seconds.
Under 30 seconds, it's the entire first quadrant of the unit circle with sines and cosines and tangents.
On speed, right?
Sines and cosines and tangents. Luca, last year, you guys know he graduated, right?
Yes.
He said in Brazil he learned a song.
Oh, who's Luca?
The cheater chart song?
Oh, you don't know.
His song was,
The cheater chart song.
1, 2, 3, 3, 2, 1, all over 2. Square root of 3 over 3, 1 square root of 3. That's what he learned.
Can I go home?
That's what it is.
Not gonna lie.
That doesn't technically get the zeros or the 90s. You're like, well, that's easy. It's on the axis. Okay. And he definitely hasn't, he made it way more fun than saying it. But the honors pre-calc class last year was like, sweet. And they sang this song and it worked for some. How the unit circle some did the over a little and up a lot. I said, let's find a way that works for you. Pause. There was a kid who went to South Campus a long time ago.
Gotcha.
And let's just say math was not her strongest point, but she wanted to be a financial advisor. Her parents were in the industry or in the business, and it's a good business to be in.
Yes, ma'am.
She wanted to follow their footsteps, but she had to get through business calculus first. And the problem is she went to college and they tested her back from the math placement exam to kind of like geometry, even though she had gotten through algebra 2 in high school.
That's gonna be me.
So, she took geometry, she was doing all right. She got to algebra 2 pre-cal. I think they actually kind of combined algebra 2 and pre-cal. And I started tutoring her, okay? Tutored her through pre-cal, tutored her through, I tutored her through, it was 2 classes before she got to calculus. She never missed a unit circle one because she used the cheater chart. She would, on the top of any quiz, any homework, any test, she would write the cheater chart and she would use it. She would only have to write it once. She would just keep on turning back to wherever she had written the cheater chart for whatever homework, for whatever quiz, for whatever test. She would always get it right. It worked for her. She got all the way through, now she's in the industry and she's doing pretty well.
30 seconds.
Okay, less than 30 seconds to write it down and use it. For some of you, this is going to be golden. Now, hold on, how do you use it though? Ready? What if I was to ask you the exact same question I asked up there on the board? What if I was to ask you sine of 5 pi over 3? Okay, what if I was to ask you sine of 5 pi over 3? You have to make a few connections. Either you have to go ahead and convert this to degrees, which some of you do, and say, oh, it's a 300 degree, ooh, which is 60 away from 360. Another way is, oh, wait a minute, everything over 3, you can always take 180 over 3 and ask, wait a minute, what reference angle, or which of these am I going to use? It's always, an over 3 is always going to be a 60. Or you can think, if it helps, if we're going to be doing radians, some of you might want to change the 30, 45, 60, 90 to be pi over 6s, pi over 4s, pi over 3s, and pi over 2s. You can change the cheater chart to have radians. But pause. 5 pi over 3. 5 pi over 3. He's this column. Go find him. He's root 3 over 2. But wait, positive or negative?
Negative.
Positive or negative?
Wait a second.
We always have to figure out where this angle is, one way or another, to figure out the signs. So we could once again say 1/3, 2/3, 3/3, 4/3, 5/3. What sign in the 4th quadrant? All students take calculus. Well, it's not positive.
Negative.
Throw in a negative.
Yes.
Or, visual people,
And I got it.
sine is the opposite side to my triangle. I'm going to the right. Well, that's not the opposite, that's the adjacent. I'm going down. Oh, opposite's negative. That works too. Let's try another one on the cheater chart. What if I was to ask you for something like tangent of 4 pi over 3? That's no fun. It's another pi over 3. Let's do something else like 3 pi over 4. 3 pi over 4. Just because I don't want you guys to ignore the sign, let's start with the placement of 3 pi over 4. Once again, you can convert to degrees and think of it that way. 180 divided by 4 is going to be a 45. 3 45s put together. But the rest of you guys, let's take one whole calzone, goes all the way, right? But 3/4, aren't I just 3/4 of the way there?
Yep.
Cool, second quadrant. What's tangent in the second quadrant? All students. Sine is positive, not tangent. Okay, negative. And then, he's a 45. Cool, it's always 1.
What?
He's a 45, always 1. He's a pi over 4, always 1. For those of you guys that are more visual, it'd be a 45, 45. So you can think of, you have a negative root 2 over 2 and a positive root 2 over 2. Divide the two, they cancel out, it's a negative 1. That works too. Want to do another one? What if I was to do, cosecant?
Oh.
It's okay, it's okay. It's okay. Of 7 pi over 6.
No, I gotta go.
What quadrant? What quadrant?
Third.
Chris, hi, focus.
3.
You guys are helping each other, that's good, focus. 7 pi over 6. Why 3? You have all 6 and you have
And then you have one more.
one more. Okay, third quadrant. All students take. Who's positive in the third quadrant? Tangent and cotangent, not him. Fine, negative. Wait, but who is cosecant? Cho. That's hypotenuse over opposite, which is the flip of so.
So.
He's 1 over sine.
So cheap.
He's 1 over sine of, wait a minute, hold on. And over 6, isn't that just like a 30 degree?
Maybe?
Oh,
Oh, yeah.
he's 1 over sine, so it's going to be, what do we do to fractions if it's 1 over? We could write it 1 over 1/2, but can't we just think of reciprocal?
Yeah.
Oh. 1, 2, 3, 3, 2, 1, all over 2, square root 3 over 3, 1 square root of 3. It's a way. It's a way, but is this the best way for everyone?
No.
I don't think of the cheater chart at all. Because my brain, I like just knowing, well, no matter what, you have to figure out where the angle is for the quadrants. You have to figure out for the sines. I like knowing if it's an over 3, it's over a little down a lot. It's always going to be a 1/2 for x or cosine and a square root of 3 over 2 for sine. And I like visualizing because I know, oh, it's a positive cosine, it's a negative sine. I like that. Helps me with my sines, and I can visualize the over a little down a lot. Just thinking of my 5 numbers. The zeros and the ones are only on the axes, and the 3 ones are, well, this is the little, this is the middle, and this is a lot. Little, middle, lot. That's how I think of it, but that's not necessarily best for all of you. Some of you, literally, this isn't going to cut it. You're just going to have to write the entire unit circle and then go using it.
Yes.
And some of you, that's the way it's going to work. Some of you are going to write the entire first quadrant and say, you know what, if I could just get the first quadrant, who the pi over 6, pi over 4, pi over 3s are, I can, in my mind, flip it, and I can actually get to where I need to go for all the rest. Maybe you only need the first quadrant. But we got to find a way that works for you. So guys, what have I shown you so far? There's triangles, geometry, SOHCAHTOA, CHOA-CHOA-TOW. Attaching every over 6, over 4, over 3 with a triangle and using the opposites, adjacents, and hypotenuses. That's one like triangles. A second way is with the x's and y's, the coordinate points, and just memorizing the circle itself. Pulling out the sines, pulling out the cosines, and going back in our notes to this little chart that said, hey, here's how you can use the x's and y's to solve for everything. That's another one. Using the triangles, using the circle, and number 3, cheater chart. Now, do you want to see one more? George Corey, if you know.
I know which
He
one.
found online, because he just it kept on slipping, he kept on not remembering the unit circle. He found a finger trick for the unit circle. How many angles are there in the first quadrant? 1, 2, 3, 4, hopefully not 7. I think only 5.
Yeah.
0,
No way.
90, 30, 45, 60.
I'm showing you.
Wait a minute.
How's she doing that?
That's a
0, 30, 45, 60, 90. I'm showing it from your perspective.
0.
You would probably want to use your left hand.
Left hand.
0, 30, 45, 60, 90. Wow! Pause. It gets cooler. Ready?
Then you flip it.
And then, now pause. It gets better. Shush. Okay, I will use your left hand to use the apple. Okay, ready? Question. What's biggest at 0? Sine or cosine? Cosine is the x, right? Cosine is biggest, sine is smallest, right? Okay. Ready? Well, let's do the easy one. Let's do pi over 4. Okay, pi over 4 is this one, 45, right?
Yes.
Fold it in.
Oh.
Root 2 over 2. Root 2 over 2.
Oh, no.
No way.
Root 2 over 2 is 2 over 2. Whoa! Ready? Wait, let's see if it works. Ready? Oh, pi over 6 or 30.
Oh, 3 over
Root 3 over 2 cosine 1/2 sine.
No. What? I don't understand.
No, just do this.
Root 3, count them, 1, 2, 3, root 3 over 2. The x or the cosine always comes first or on top, the
Yeah.
sine's always on bottom.
Yep.
Root 3 over 2, because there's a 3.
How do you do?
And then 1 over 2. Pause, does it still work? At pi over 3 or 60. Half 3 over 2.
Oh my gosh.
Cosine's on top, sine's on bottom.
No.
Now wait. Oh, what about a 0? Oh, it doesn't work now, does it?
Nope.
What's root 4?
I don't believe you.
2. What's 2 over 2?
What?
1.
Oh my goodness.
1. And then is there anything?
What?
0. 1, 0. And then this one? 1, 0. Sorry. 0, 1.
Can I get
So, root 2 over 2, root 3 over 2, 1/2 root 3 over 2, 0, 1, 1, 0. Now, just saying,
How did that happen?
are there a lot of ways to do the unit circle?
Yes.
Could there be another way besides the finger trick that works for you online? It could be. He found this one when he was in Calc B, C, A, B.
How did that
Calc B.
happen?
It worked for him. Just look at it on the test and he's doing it. Okay. I want you guys to, ready? We have 5 minutes, we're gonna practice. One of the ways that works for you. Sadly, I can't do all of them, so I'm gonna do a different way each one.
Oh, dang it.
Guys, which one looks the hardest up here?
All of them.
Hardest, you have to choose.
The negative.
Yeah, B was pretty bad.
Let's do D.
Why that one?
We haven't done, calm down. We haven't done a pi over 3 and a 1. A pi over 3 and a 1. Now, if you're one of those ones who likes the finger trick, negative pi over 3 is going to be,
I like it.
negative pi over 3 is going to be in the 4th quadrant.
I like what I'm saying, gentlemen.
My visual people, it's going to be over a little, down a lot. 1/2, negative root 3 over 2. My finger trick people,
Like this one?
pi over 3 is a bigger slice than all the rest, so of the middle ones, it's going to be the biggest one. So it's going to be root 3 over 2 and 1/2.
Oh my gosh.
I have to think about,
Do that.
wait a minute, pi over 3.
I think I need to figure it out.
I need these hands.
Oh, when you flip it, struggle. I'm not sure if you want to flip it.
Yeah, aren't you sure?
Struggle.
Because cosine is going to be still your thumb. Yeah, that's going to be a struggle. If you flip it, you have to flip the side.
Just look at your pinky.
We'll just stick with the first quadrant. Guys, we'll stick with the first quadrant. Because then pi over 3, I have 1/2 root 3 over 2. Okay. So, whichever way you get there.
No.
It's going to be a positive 1/2 and a negative root 3 over 2. My cheater chart, people, a pi over 3 is going to be 60 degrees.
Yep.
Okay, stop talking with your hands to yourself.
Jeez, Michael.
You do like the shadow trick, it's very fun. Okay, pause. Now you're all trying it. Question. If you have the point, or if you have the cheater chart, you're looking at the 60-degree one. You're in the 4th quadrant. What's sign going to be?
Negative.
Yeah, and not just negative. All students take calculus. Cosine's positive, sine's negative, but what's the value? Cheater chart, look at the 60-degree column. Other people look at the point or the triangle.
Root 3 over 2.
Root 3 over 2. What's cosine going to be? Cheater chart, look at cosine underneath 60.
1/2.
Or the point, look at the x value, 1/2. Tangent. I take y over x, my coordinate people. Now this is where it gets a little funny. If I divide the two, it's nasty. Except the 2's cancel out. So you end up with negative root 3. The 2's cancel out. It's negative root 3 over 1. Cheater chart people, look at 60 degrees. You have
60.
square root of 3, right?
Yeah.
But all students take calculus, tangent has to be negative. Cosecant. I flip the sign, which you guys do it after a while. It's going to end up being negative 2 over root 3, which we rationalize. So you would flip these two and rationalize. Secant. You take cosine and flip it, so 2. And cotangent. You take tangent and flip it, which will be negative 1 over root 3, which is the same thing as negative root 3 over 3. Some of homework is going to say, hey, here's an angle. Figure out the quadrant, figure out the signs, and find me all 6.
Oh.
Could you use a triangle from geometry? Yes. Could you use just the x and y? Yes. Could you use the cheater chart and then flip them all? Yes. Okay? Now, what else could show up? What else could show up? I know we're right here at the end, and I think this is the last page of notes. What else could show up is some ideas asking for sine and cosine, what they range between. And as we already pointed out, every sine goes between negative 1 and 1. And so does every cosine. They're going to repeat every 2 pi. And I just wanted you guys, if you want to take a picture of this on the way out, there are going to be a couple times in homework where it says to use these properties. The even and odd. Take a quick picture if you're not able to write it down. I'll check your notes tomorrow and make sure you got it. But these properties might show up for 1 circle 1. Go practice that even circle. Homework 4 Tuesday tomorrow. I'll double check on these properties that you understand it tomorrow. Bye guys. Think tonight in homework. Which way do you want to choose? You got to choose one. Which way do you want to choose for you?